on the MWC Las Vegas show floor is Leighton Carroll. Leighton is president of Galtronics. Leighton, it's great to see you.
Great to be here. Thanks for having me.
So start off, tell us a little bit about Galtronics and what brings you to MWC.
Yeah, so Galtronics look, I think it's a really cool company. It's actually part of a larger company called Baylin. We do multiple things. Part of that is we have a sister company, for example. We produce equipment that's going to be used in the NASA Artemis space mission for communication to the lunar lander from Earth. That's cool, right? Galtronics, as an example, some people know us for putting antennas into Samsung mobile phones. If you know someone who's had it, we've been involved in that for years. We have an embedded division. Customers like Netgear, if you get your wireless router from a cable company or a fiber provider, we make a lot of the antennas in that. A brand name automobile OEM that you would know, when their next flagship SUV comes out, the wireless enablement of the customer experience is us, right? And then finally, the reason I'm here is Galtronics infrastructure, and I'm actually really excited about the business because we've been really working hard for the past several years on some really interesting technologies. We do macro cell tower antennas, outdoor small cells, in-building wireless, stadium antennas, and most recently something called multi-beam antennas. And we've been getting a ton of traction with it, and it's a lot of fun, and so that's why we're here.
Let's dive a little bit deeper into one of those you mentioned, multi-beam antennas. What is their role in the mobile ecosystem, Leighton?
Yeah, so multi-beams as a technology have been around for a while. Think of it as, everyone knows what a macro sector is, and there's all types of technology. Massive MIMO is a great example of recently in 5G to add beams or add capacity, add spectral efficiency for a cell tower, right? Well, multi-beams have been around, but they've been very kind of focused around adding fixed beams within a given sector. And what we found is that they are an amazing solution for dense traffic environments. That's where they've been. The rub on that, though, is that panel-based multi-beams, the old style, had limitations and had problems with beam stability and canceling themselves. The solution has been these globe-looking lens antennas. They're great, big, huge things. They worked really well, but they were crazy expensive for wireless operators, and so they weren't widely deployed, only for set things like stadiums and other things along those lines. We have patented technology, panel-based multi-beams, that allow our customers to deploy these in a wide array of use cases. And this started, really around crowds and dense traffic environments, festivals, concerts, things like that. And now carriers are taking us in places that we didn't anticipate. Carriers are actually taking us into fixed sites, macro sites, to cover dense traffic locations. Airports like JFK, city centers in the Midwest, and it's been really kind of a neat story and something we're proud of that's growing.
So what's the most important performance metric for multi-beam antennas, Leighton?
So it's actually a great question. So I'll give you an example. We had a carrier recently that traditionally they would have used these big 64T, 64R integrated antennas to cover huge traffic. Well, one of the things about massive MIMO and the technology is in dense traffic, it gets saturated. Why is that important? User data speed falls linearly with the number of users on that system. A massive MIMO antenna, it actually retains the data speeds because of the way that the beams are set up within it. It paired with a 4T, 4R antenna, our carrier partners are seeing they're able to continue to support the data experience in a hugely dense traffic environment. I'll give you some real easy examples. We did a concert, we didn't do it. Harry Styles had a concert in Ireland, right? Bruce Springsteen had a concert in Italy, as examples. Wireless carriers in each of those countries, for example, Air in Ireland, they didn't do the big antenna solution. I've got this beautiful picture, 80,000 fans at Slane Castle in Ireland, packed, going crazy for Harry Styles. They had coverage with Air because we had a Galtronics multi-beam sitting there covering that field. That's where that product really excels, and to where it's had an advantage is now developing advantage over some of these legacy technologies.
Let's just gaze very briefly, if we can, before we wrap up, Leighton, into the future, look at our crystal ball. What kind of technologies or markets are on the horizon going forward for Galtronics?
Well, it's actually fun for us. So we started with, we've always been super strong in building. We've been super strong in stadiums. We, maybe naively assumed that the Harry Styles concert situation, right, would be the only place we take these multi-beams. And when we started, we only really had one, right? We now have multi-beams and more in our funnel that are coming out across multiple spectrum, across multiple technology. This is another advantage.
Yeah.
5G and LTE in the same physical antenna, and they're getting deployed in places we never anticipated, right? City centers on a rooftop, as opposed to a big 64T64 antenna. That's super cool, right? We had our antennas deployed for a Papal Vision in Europe. Didn't expect that. Seeing our antennas now going into stadium applications. Why? Because the legacy globe-like antennas, they work well, but they're so expensive. And when you have a panel price and that level of performance, it's just go, go, go. So for us, it's how do we solve as broad an array of use cases for our carrier partners, and some of which we don't think of. And that's both in the US, Canada, and internationally, and that's what makes this exciting.
Well, Leighton, it's been great to find out more about Galtronics. We wish you a very successful MWC Las Vegas and a very successful rest of 2023. Thank you very much for joining us.
Thanks for having me.
Thank you.